Hi everyone, welcome to the webinar on geospatial technology used by geographers to solve real-world challenges and complexities. Hexagon's safety infrastructure and geospatial division improves the resilience and sustainability of the world's critical services and infrastructure. Our technologies transform complex data about people, places, and assets into meaningful information and capabilities for better, faster decision making in public safety, utilities, defense, transportation, and government. Now, I would like to introduce our speakers. We have Mr. Ashish Joshi, Senior Manager. He has been with Hexagon since October 2021 and has done several on site trainings and installations of Hexagon's geospatial software for educational institutes and defense clients. He has also worked for clients like MCGM and NABARD. We also have Rajesh Kumar, Deputy General Manager. He has been associated with Hexagon since September 2022. He has over 18 years of rich industry experience in field of photogrammetry, GIS, and remote sensing. Before handing it over to our speakers, I would like to mention that if at any point you would like to ask a question, please enter it in the questions box. Our presenters welcome your questions and will address them later in the presentation. If we are unable to get to all of the questions in our live session, someone will reach out to you after the webinar by email. Just to let you know, we will also be sharing the recording of this webinar after the session. Over to you, Ashish.
Divya, am I audible?
Yes, Ashish, we can hear you
Yeah,
now.
yeah. So good afternoon, everyone. I welcome all the students, all the respected professors and research associates for this webinar on geospatial technologies for geographers. Uh, so this is our agenda. We'll be covering the following topics today. I'll be giving a brief overview about Hexagon, what is covered in the educational product portfolio of Hexagon. We'll be showcasing some of the Hexagon solutions and use cases, which will be very useful for the geographers. And in the end, we'll be taking your questions. So as Divya has asked you, please post your questions in the chat box. We'll be addressing it later in after the presentation. So to start about Hexagon. So Hexagon is a global leader in information technologies. Our specific focus is on basically geospatial and industrial enterprise solutions. We are more than 23,000 employees working in 50 countries. We have provided solutions to a wide range of industries all over the globe. We spend 10 to 10% of our net sales in R&D. Over the years, Hexagon has acquired leading brands like Erdas, Luciad, Leica, Intergraph. And with the help of all these latest technologies, Hexagon is providing enterprise and cloud platform-based solutions in the geospatial domain. And we also provide public safety and utilities solutions in the safety and infrastructure domain. To speak about Hexagon India, we have got presence all over the country. We have got offices in 14 cities in India. We are headquartered in Gurugram. We have got regional sales offices across all major cities in India. And our R&D centers are located at Hyderabad and Pune. And we have a strong team of sales, technical and techno-commercial people. Over 2,000 employees are working to support our customers all over the country. Uh, Talking about the GeoOps challenge in today's world, like Hexagon solutions provide the means to create the GIS, photogrammetry, remote sensing, and survey data, which in turns needs to be connected to the operational domains, like in various industries. And Hexagon product portfolio fulfills this gap, which helps to connect this geospatial data with the operational domain, like incident management system or SCADA integration, different IoT sensors, or multi-agency coordination like dial 100, or and then the decision makers are able to use our systems effectively for the corrective action. So Hexagon has provided solutions to almost all industries like smart cities, nations, transportation, forestry, safety and security, water department, agriculture department, power and utility, and defense also. to name some of our key customers, like dial 100 for Madhya Pradesh Police, dial 112 for Uttar Pradesh government. We also provided our solutions to ISRO, Mahageneco, all these clients we have served over the years. Coming to educational product portfolio. First, I will speak about our major product portfolios. So we have got our three important product portfolios. First is power portfolio, which consists of geospatial COTS solutions products. AMAP portfolio, it is basically a unified geospatial platform which is provided to user and which has inbuilt libraries. So the user can use these inbuilt libraries and configure his own workflows and solutions based on his business requirements. He can design a web-based solution or a mobile solution or a rich client-based solution also. Luciad portfolio is a development-based portfolio. The developer can develop solutions which are primarily designed on a GPU-based technology, and they are basically used for real-time situational awareness. So I will be speaking about Power Portfolio today. So Power Portfolio has got three compartments, as you can see in the slide: producer suite, provider suite, and platform suite. So producer suite, as the name suggests, all these solutions, they produce the GIS, photogrammetry, and remote sensing data. So ELDAS Imagine is our remote sensing software, which produces the remote sensing data. GeoMedia is our GIS solution, and Imagine Photogrammetry is our photogrammetry solution. So once this geospatial data is produced, this data needs to be managed and some analytics needs to be developed on this data before we pass this data to the solutions which we configure. So the provider suite fulfills this gap of handling the data management and delivery of the data. And when you come to the platform suite, we have got web-based solution, that is WebGIS, GeoMedia Web Map, mobile application, and the rich clients. So this is how our power portfolio comprises of three compartments. So now I will be speaking about the producer suite, which has the ELDAS Imagine for today's topic. So remote sensing for educational. So ELDAS Imagine Professional is our flagship product, and it is very widely used all over the world for from all the remote sensing professionals for different analysis and processing of the remote sensing data. To name a few, the land and urban planners use our software ELDAS Imagine to monitor and support the decision making for sustainable urban development in dense urban environments, which changes. It is also used for the photogrammetric tools where you can prepare the digital elevation model with the help of stereo pair of images. Transportation analysis also uses it for the processing and monitoring of the infrastructure. And to plan a mission in defense department, defense analysts also use the ELDAS Imagine. So these are some of the key functionalities of ELDAS Imagine. So image enhancement, as you know, we get images from either satellite or aerial sensors, or right now in today's world we get from the drone sensors. So once you get the image, you need to do image enhancement for data extraction. So all the tools are provided in ELDAS Imagine. In the photogrammetry module, you can create the digital elevation model, orthophoto, and carry out the ortho rectification. Once you get the digital elevation model, you can prepare slope and aspect map from it. You can also carry out intervisibility and viewshed analysis, like the user observer is standing at one place and he's observing one area. So what is the area visible and what is the area which is not visible? There are certain indices which are inbuilt in ELDAS Imagine, like vegetation indices, mineral indices. Unsupervised and supervised classification tools are also available in ELDAS Imagine. Then chain detection, as you know, you can compare images of the same area of the two different time intervals, and you can detect the change which has occurred on that particular land parcel. And spatial modeling is an automated workflow tool where you can configure your models as per your business requirements. So coming back to the education products, so ELDAS Imagine Professional is our base product, and along with it, there are certain add-ons which are provided, like Imagine Expansion Pack, which primarily includes 3D visualization, automatic change detection, stereo feature collection. Then there is LDAS ER mapper, which is primarily used for image processing, and the workflows are primarily focused on oil, gas, and mineral industries. Imagine photogrammetry. You can do the analytical triangulation. You can orthorectify the imagery, and you can generate the terrain models. Once you generate the terrain models, you can generate the digital surface model using imaging DSM extractor. And if you want to edit your terrain data, then there is an imaging terrain editor. So all these modules are supplied with the education kit along with the LDAS Imagine Professional. So now coming to some of the use cases which will be very useful for the geographers. So first is urban sprawl analysis. So as the name suggests, urban sprawl is nothing but rapid expansion of geographic extent of cities and towns. So as we know, there are certain vacant and undeveloped lands near the cities. Right. So once these lands are fulfilled with concrete structures, it is the indication of urban sprawl. And this has got a very huge impact and adverse impact on environment and human life. So the civic authorities or the urban local bodies need to monitor these urban sprawl. So satellite images are used for these tools. There are multiple tools which are provided in LDAS imaging. I am just showing you one of the tools where we are comparing the satellite images of the same area. And you can see the land is vacant, completely vacant and undeveloped in 2008. And as we are seeing, the concrete structures are coming up yearly. So this is how we can monitor the urban sprawl. And there are different tools like chain detection also, where you can actually measure the spread of the urban sprawl and save, and you can get the measurements also. And you can use it for your decision making and corrective actions. So this is very useful for the urban and civic authorities for urban sprawl analysis. So next thing I'm coming to is encroachment identification. So this is again a very huge problem for the municipal authorities or even forest authorities, government authorities, because the land is encroached by some people or some authorities. So again, here if you see, LDAS Imagine provides automated tools where you can build a special modelers. So here we are comparing two satellite images. One is of 2018 and one is of 2020. So encroachment is identified visually first, and then we are capturing the signature of that particular chipset, and then we are feeding that to the model which we have created. And in turn, software compares the two images and it uses that signature which has been fed, and in the end it will identify the exact proportion of the exact impact of the encroachment which has taken place on that satellite image. So as you can see, the red area highlighted by the red color is the encroachment which has taken place in 2020, which was not there in 2018. And you get area also, perimeter also, everything you get in this tool. The next thing I'm coming to is crop health analysis. So crop health analysis is very important for farmers and agricultural departments. If crop health is monitored correctly, the corrective action can be taken. So here we are basically calculating greenness index. So one is NDVI, that is normalized differential vegetation index, and one is green NDVI. So green NDVI calculates the health and density of the crop. So here we are using a satellite image and we have built a model. So this is a satellite image, and after running the model, we are getting, so this is the output of the classified image. So green area indicates the crop is healthy. And once we get the crop status, we can actually verify it with the drone image, actual drone image. So we are selecting a small land parcel here, which has been shown by the classified image. And for this particular land parcel, we have a drone image as well. So now I'll be using the drone image on top of the classified image. And then I'm using some of the tools in LDAS Imagine to cross-check that result, whether it is really green or not. So similarly, LDAS Imagine provides several indices like mineral indices, soil indices, water indices, snow indices, using which the images can be classified and correct output can be saved for future references. And once the image is classified, you get different classes as well. You can also get the area, it is called the crop acreage of that area. And now we are coming to the environmental impact. And now I would like to hand over to my colleague, Mr. Rajesh, who will take it further.
Yeah, thank you, Aziz. After a very good afternoon to everyone. So now further, I will lead you through some of that use cases relevant to the environmental impacts. And basically, I'm going to talk about forest fires, water body detections, deforestation, land use using indices, landslide solution, and we'll try to explain how we can achieve the actionable information from these use cases, and that will basically help in our decision making using geospatial technology. So first use case that I have considered is a forest fire detection. See, forest fire is a part of nature, and its impact deadly on wildlife habitat, destroying homes and even emitting harmful gases that is really dangerous for the human health. These natural environments is disrupted because of these fires, which can cause and harm to enormous natural areas, as well as human lives and living creature death. If I see forest fire, basically there are two main factors which are responsible for all these forest fire, that are nature's and the human beings. Forest are forest fires are caused generally by a number of circumstances, including unplanned urbanization, what we have talked about right now. Urban sprawling is one of the reason behind that. Sometimes carelessness is a responsibility sort of things that basically trigger these forest fires. And it is very important to track and analyze this trend of forest fire. We can monitor this forest fire using some of the indices that are available with radar imaging. We have indices in a radar imaging that is called burn area index, using which you can calculate the burn sensitivity zone. You can create when you can create a burn severity where all burn severity are there. Here basically we use thermal and near infrared band to calculate. We have a spatial model for that part. So using this thermal and near infrared band, we can calculate forest fire burn severity. Here, just using one spatial model, we have given inputs as a thermal near infrared imagery here. And once we run the model, we used to have a rasterized image which indicates where the forest fires are basically prone of that. A severity of that forest fire is, and that further you can convert into polygons as well. Once you get this forest severity index, you can correlate with different datas like demography data, soil data, flora and fauna data, and by correlating your fire severity index, burn fire index, and this data, you can find out impact over the human health, impact over the soils, impact over the forest habitat. This way, this indices can basically helps you in interpreting things. Second use case that I'm going to talk is regarding water body analysis. Here, delineation of water line change is very important to important to access and access the loss and cause due to flood inundation. So once you have during monsoon season, generally what we observe during a monsoon season, clouds used to, sky used to be full of clouds. In that case, optical sensor satellites are not much use of that. So in that case, radar play a very important role because radar is based on the active source of energy where there is no impact of environments. Even wavelength is too high, which can penetrate the cloud and collect the information. Here we have to consider the radar image. If you see the Sentinel-1 data for the 3 months, that is April to April, May, and June. Basically, what I'm trying to tell you is like from pre-monsoon to monsoon season. Where if you see inside the yellow box, water line is getting changed from April to June. But just imagine basically provides a tool to analyze this radar set imagery where you can delineate this water line very easily. Just on a click, you can analyze the water, and then using the slice, you can delineate the complete water, and then further you can vectorize that information. Here we have extracted all the flood area extracted from this 3 months radar imagery. You can see the water line is being changed. In a case of June, there is a higher coverage of water is higher in comparison to the month of April. Further, again, we have correlated with the data like village data, subdivision, district data with this water delineated polygons. And you can see some of the villages marks in red are submerged inside the water in month of June. So this SAR imagery processing will help even authority to access to the damage, how much damage has been caused by these floods, and how much loss has been made, and accordingly, authority can take a decision on that part. Next, our case is a deforestation. Today, deforestation is a major challenge for us because the loss of trees and other vegetation causes a climate change like desertifications, soil erosions, few crops, even flooding, increasing greenhouse gases in the atmosphere. So deforestation causes a host of problems. So to solving this problem, it's required to monitor this. Monitoring of deforestation is very important. Where geospatial technology play a very important role. By analyzing the deforestation trend over the year, an informed decision can be taken to mitigate the problem. Here we have took a satellite imagery of one of region from 1995 to 2007. You can notice how year on year forest line is getting changed, which ultimately impacting our environment. A suitable action like plantation in the area can be done to control this deforestation, and geospatial technology can play a good role even in monitoring the plantation part, which I will be discussing in a coming slide. Here I'm going to talk about some of the indices. Basically, if you say like spectral indices are basically combination of spectral reflectance of two or more wavelengths that indicates relative abundance of feature of interest. Here I'm going to talk about NDVI, that is a normalized vegetation index. There are several indices are available inside ADAS imaging, which can be used for different sort of studies. NDVI is very useful in terms of if we talk about either precision farming or environmental impact studies. In case of precision farming, if you see vegetation crop health monitoring is a very important. Even the crop yield calculation is very important. So ADAS imaging have all sort of indices available, which can help you in calculating the crop yield, monitoring the crop health, calculating the crop yield. So here we are using a multi-spectral image to calculate. So if you see there is a multi-spectral image, and multispectral image have several bands, including near infrared, infrared, and we are calculating NDVI using a spatial model where we have you can drag and drop the operators. You can apply the indices. Even if you for using this spatial model, you don't need to have expert in a spatial model. Even if you connect at the wrong location, software will indicate by the redlining the things that you have done the wrong, and you can connect that operator at a particular port, and you can go ahead with that. Here we have selected the number of sensor. If you see, we have the bunch of indices available here, and if you run the spatial model, you will get the result in a left side bottom. So further, some of the users basically interested to have in a color image. So you can also use some color table here and apply the color table. Then you can use on color of degradation using, you can define some input to your color table from your file. So that accordingly, and you can add a preview for that part. And once you run the spatial model, you will get a color image over here. So these NDVI results, the area which is marked in the greens basically indicates the vegetation in health. So healthy, greener the indices, healthier the plants. Even in a panchromatic image, this region was the white. So whitest part was the basically which was showing the healthier crops. Next, I'm going to talk about the landslides. Landslide zonation. If you see, landslides are the basically downslope movement of earth materials under the force of gravity. If we go in a hilly regions, we noticed year on year that so many lives is going in a danger thing because of this landslide. Lots of people died because of in a hilly terrain because of landslide. So landslide donation is a very important. If you know how to identify the area, you can basically define that area, and you can take a proper decision at a right time. Here we have to took a multispectral images, and out of that we have calculated a DEM, digital elevation model, to generate a digital surface to have a 3D input of that particular area. Out of that, we have also considered certain layers like shaded relief, slopes, aspect, soil types. So if you see here, that like we can, these are the basically digital elevation model. Out of this, we have calculated shaded relief, And top of that, we have calculated slope. So if you see, there is a slope between 0 to 10 degree and 10 to 20, 20 to 65. So those area which are having higher slope from 20 to 65 degree are more prone to the landslide. Again, we have calculated slope out of that. So after slope, we have calculated the aspect. So aspect basically tells the direction of the slopes. So higher the steeper the slopes, direction, these play a very important role in calculating the landslide. And again, another factor we have considered, that is the soil polygons. Soil having all the information like hard, rocky, and soft soils, and then drainage and road networks. Based on that, we have run our spatial model. So once we have run the spatial model, in a few clicks, you will get the result of lands. These are area which is marked inside the red polygon are the basically area which are more prone to the landslide. So anyway, so anything, I mean, authority can plan accordingly for that particular area, which can be demarcated using this geospatial technology. Further, you can attach photographs or videos of that particular zone with that information. So basically, this will help in a decision making things. Further, if you see during the most of the landslides being occurred in a rainy season in a hilly terrain, where where optical data are not sufficient during that time, region behind again it's a cloud full of skies used to be full of cloud. So in that case, we don't get a very good information from optical satellites. So radar play a very important role in that seasons. Radars, imagine, have a capability to process all the SAR images. So just we are trying to show you how SAR images is helpful in accessing the landslides and its impact. Here we have took Sentinel-1B data for 2 dates. One is left side is a before event, and right side is the post event imagery. You can see area inside the red polygon. So these are the basically area where the landslide has occurred. So how we can access the impact of this landslide using this, that we can see further. So here again you can see impact of landslide. These are the basically again SAR image, and the area marked inside this yellow polygon, this bluish area, are the basically impact which occurred due to landslide. Radars, imagine, have a basically a coherent change detection algorithm which helps in identifying the even smaller pixel level change, if anything, find based on the phase difference actually. Here, just to compare the things, we have taken here same area optical satellite. Somehow we got optical area for optical imagery for that particular area. You can see the impact. I mean, this is the post pre-event photograph. This is the post-event photograph. So these are the events. These are the basically impact caused by the landslides. But visualization and accurate calculation of impact, it's not possible using optical satellites, where you cannot see minor things using your own eye. So sometimes interpretation is not much better. However, the resolution part, if I say resolution is much better in case of spatial resolution, much better in case of satellite imagery. But to calculate accurate, impact, SAR helps us a lot. Here in the left side, you can see we have overlay this SAR imagery data over fused data with optical satellite imagery. These all reddish and bluish area is the significant changes that occurred because of this landslide. Further, using this coherent-based change detection, we have calculated pixel level area where the highest probability of change can be calculated using a SAR module of ADAS imaging. Further, suppose processing of radar imagery is too tricky actually. Someone need to have a good expertise to process the SAR imagery. So some ready-made data is also available in a market. So we have provided tools inside the DAS imagery where you can find another utility or interferometry from where you can directly order radar imagery, processed radar imagery from your software. Just you can mark the polygon and you can generate the order to place the order for processed satellite processed SAR images. Again, everyone has a different application of SAR data. Some may be from the mining, some may be from dam monitoring, some may be from city infrastructure monitoring. So based on utility, like here area marked in a red, if this is my area of interest, so I can mark my area of interest on the image and can define our application in that. And based on that application, we can upload the order for the, we can generate a service request for that part. So we can get a directly processed data, radar processed data for that our area of interest. And that basically helps in taking a decision on the subject. Last, I will talk about the image chain. Basically, when we visualize image, sometime for interpreting the image, you need to display your image in a different way. Sometimes we want to see the panchromatic image. Sometimes we want to see, a multi-spectral image. Even a multi-spectral image, we used to change the different band combinations, because once you change each band contains a different sort of information. So based on requirement, we used to change our band combination to visualize the change. Here in ADAS Imagine, there is a very good tool that is image chain. If you are using image chain to display your satellite imagery in a viewer or radar imagery, so in that case, what software does? Software basically read the metadata for yourself and give you multiple options to visualize the things. So if you see, once you load the image in image chain, in that case, you will get a default option for multispectral. Even you can see the panchromatic image, pseudo color image, thematic map, relief map. So for having all these things, you need to process first. Even if you want to see thematic map, then you will have to create a thematic map. So for that, you will have to do some processing of the data. Then you will have to then you will be able to visualize the thematic map. But if you're using image chain give you a default value where you don't need to reload the image. Basically, it will automatically generate all these combination: multispectral, panchromatic, pseudo colors. So just on a click, I mean, if I on a click a pseudo color, I will have the visualization of that particular image in a pseudo color. So basically, these tools helps us in a visualization of image, and visualization of image that saves our time to process and reload every time to one image. In the last, I will basically talk about our benefits of this power portfolio. Our portfolio provide a consolidated software for remote sensing, photogrammetry, LiDAR analysis, even before the basic vector analysis, radar processing, into a single product. It also helps basically in, if you are a programmer, you are well versed with the Python, you can play with them. Image is just things where you can play with the different band combination to extract different sort of information as per your requirement. So using Python and ArcPy, you can do the same. Even we have a spatial modelers, which that is basically OGC compliant process, which that recipe gives you output, which you can directly publish in an enterprise GIS as well. So which we will be covering in a coming webinar, how our enterprise GIS is helpful to the industry. So in a short, I will just tell you, we as a Hexagon provide a single window solution for all these your needs relevant to the GIS photogrammetry. So that's it from my side, and we welcome your question and answer. Divya, over to you.
Thanks, Rajesh. We have a few questions submitted for today's webinar, so let's get started on those. The first question that we have is, if I do SVM classification in ArcMap and the output of land cover map is in the form of .dbf, how should I open the classified image in ORDAS?
RDAS Imagine supports multiple sensor formats for import and export, so that format should be available there. If it is not, there is also option to import your files from PostgreSQL and SQL Server also. So .dbf is basically a database file, so that can be converted to any suitable format and open in RDAS Imagine.
Thanks, Ashish. The next question we have is how to estimate crop yield from NDVI for any region.
RDAS Imagine provides you the NDVI classification, and after NDVI classification, you get the crop acreage. That is the area for a specific crop class. To get the crop yield, you need to develop some algorithm, right? You need some historical crop data and the weather information. So that portion is needs to be done. Crop acreage is available in RDAS Imagine.
Okay, our next question is whether ORDAS has any inbuilt model like cellular automates or CA Marco for modeling urban growth.
Sumit, you can take this question.
So, good afternoon. So we don't have actually this model, but one of our client has actually worked for that. So this model can be developed in ADAS using spatial model. Basically, the current your urban patterns and the metrics for your changes and how it is going to be reflected. So inbuilt model is not present, but it can be made. Some of our users has actually made this. Thank you. Next one, please.
Thanks, Sumit. So the next question is, will ORDAS integrate other machine learning based classifiers like SVM, REF, etc.?
Yeah, I'll just take this. Yes, we do have actually in later in some upcoming webinars, we're going to talk about spatial model more. So there we have other machine learning based classifiers like SVM, random forest, BART, line regression model. So these will be available. These are already available in ADAS spatial model.
So the next question is, for flood monitoring or water analysis, is it mandatory to do some pre-processing in the case of using Sentinel-1, or we can use Sentinel-1 image in ORDAS Imagine directly?
We can directly use actually one image in ADAS Imagine. Directly we support the manifest.trace file. So using that we can directly use within ADAS. Thank you.
Our next question is, how can I do supervised classification of LULC in ORDAS? Can I get any video guide? Also, which Landsat image should be downloaded from USGS?
Yes, videos are available, and RDAS provides a supervised classification workflow where you can create the signature and you can classify the image based on that thing. So Landsat image can be downloaded from USGS as per the data, as per the area you select on the USGS map.
So next we have a price related question. I think I will request Shiva to reach out to the email IDs we have on the screen for the same. We'll take the next question, which is related to how can I do radar interferometry for DEM generation?
Yeah,
How
There is
can
a
for
I do
set.
radar
radar
interferometry, for radar interferometry, you require star interferometry license. So that is also available in education, but it is not in the education pack. Once you have the interferometry license, you can generate that DEM for interferometry data. Thank you.
Thanks, Amir. The next question is, can we develop soil erosion model like Russell and ODAS Imagine?
So that we are not aware about. So if you have some model and how the calculation to them, you can try for that. We have developed for soil classification and all. So maybe it can be done, but we need to see the algorithm, then only we can.
So just I will add on that we have a spatial modeler where we have a different operators. Even you can basically all these things depend upon the band combination, how you are manipulating, and how you are how formula you are putting to calculate the information, right? So we have all the operators. You can do by own as well. I mean, we don't have any default model for that, but yes, by using the operator, you can create own formula. You can use your own formula to create the things to get result.
Thanks, Rajesh. The next question we have is, can we estimate forest fragmentation in ODAS Imagine?
Actually, we can do segmentation. So using segmentation, we may train the spatial model for forest segmentation, but it has not been tried yet. Maybe we can work together and try that out as well.
Okay, our
So
next question is crop classification possible?
Yes, you can classify the image based on the signatures. You can take different signature for different crops. And if you classify that image with that signature, it will be a crop based classification of that image.
Our next question is, which satellite we can use for LULC means for analysis and digitization to get proper way?
Look up LULC is based on the satellite imagery, right? So that once you train the software, once you give the signature for that particular class, yes, it will classify that, right? And further, it can be, I mean, if you have a correct input by digitization or a ground data for that particular part, certainly your data will be more accurate in that case. Output will be more accurate in that case.
Next question is, how can I do speckle filtering in SAR image?
this
There's
technique
so
filter is available within ADAS Imagine itself. Thank you.
Our next question is, can we analyze temporal soil moisture changes?
Soil moisture can, yeah, hello.
Yeah, go on,
Yes,
Sumit.
Yeah, yeah. The soil moisture can be analyzed. So obviously you can get soil moisture. You can see the temporal changes in the moisture in the soil, which is used quite a lot in agriculture and irrigation. Thank you. Next question, please.
Our next question is, how can we predict how prediction to urban explorer?
Sorry, this one actually I'm not aware
see
about.
urban. Just I will add, Smith here. Urban
Yeah, yeah, please.
sprawling is like there are so many factors for that part. I mean, one way is to like you can with the over the period if you have a different time satellite imagery, you can monitor, I mean, how your city is expanding. There is a one way of doing it. But yes, how much inflow of because once people come from outside to live in a city, in that case, basically urban sprawling occurs. So it all depends on a various factors, socioeconomic factor, and everything that will have to consider to have that one.
Thanks, Rajesh. The next question we have is, can we use ODAS Imagine in the mitigation of glacial lake outburst flood?
Yeah, so remote sensing is mainly used for analysis. If you are talking about little lake outburst, this is more of a disaster situation. So where sensors actually help the most, sensors and radars, rather than yeah. So remote sensing can be used for analysis only, where you can see why and how this thing has happened. But in case of mitigation, sensors are the best weapon for these disaster scenarios. Thank you.
Also, with that, our questions are over. Thank you everyone for joining in. This concludes today's webinar. Please join me in thanking Ashish, Rajesh, and Sumit for this informative session. Please note the email ID is displayed on your screen in case you need any further information. We will also be sharing a recording of this session should you wish to listen back to this webinar. We appreciate your time and hope you have found this webinar to be a valuable experience. Thank you.
Thank you. Thank you, everyone.
Thank you. Thank you, everyone.
Thank you, everyone. Thank you for your time.